Hello students, Miss Slyman here, talking about applications of exponents and logs. So basically with applications we mean word problems. So looking at this first one, we're investing 5,000 euro at an interest rate of 6% per annum. Per annum means annually, so we get 6% on our investment every year. So find the value of the investment after 1 year. So we want to know the total amount of money, not just the interest rate that we've made. So that means that we get after the first year, so I'm going to call that n equals 1, we're going to get $5,000 or 5,000 euros, and we get 100% of that plus 6%. So I'm going to multiply that by 1.06 because again I want all of the 5,000, so that's 100% plus the 6%. So after 1 year, let's clear this out, we've got 5,000 times 1.06, 5,300. And I could have thought about that as well. 6% of 5,000 is 300, so add it and I get 5,300. After the second year, I'm going to take my amount of money, so this amount of money, and I get 6% on top of this. So I'm multiplying this by 1.06. Well, really what I've done is 5,000 times 1.06 squared. So we're going to end up with 5,000 times 1.06 squared, and hopefully the calculator's going to work this time. Try again. So 5,000 times 1.06 squared, 5618. So after 5 years, I'm going to raise to the 5th power because my interest will have been applied 5 times. So 5,000 times 1.06 raised to the 5th power. 6,691 thereabouts. And that's how we're going to calculate it. So in this case, our equation, our general equation, the amount of our investment is going to be the 5,000. So that's my A value. And then my interest rate makes my B value, and we do 100% plus 6% to the x power. So if I want to graph my function, well, I'm going to make a very tall y-axis. Of course, my investment, hopefully, my investment's never going to be negative. Let's try to draw that. Sorry, it's not straight. So I've got most of my space up here. I'm going to put a break in my line because my investment starts at 5,000. So when x is 0, I start at 5,000. And then after 1 year, I was at 5,300. So I want to figure out how I'm going to count. 2 years is 5618. 5 years was 6,000. So maybe I'm going to count by 250s, let's say. So up here I'll have 6,000, 7,000, and of course my y-axis is in euros, my x-axis is in years. So we had 5,300 over 56, and then at 5 years. And I need to label somewhere on this axis that I'm counting. So after 5 years, we had almost 6,700. So that's going to put us somewhere around there. And of course, we've got an exponential function going up pretty quickly. Actually, not so quickly because my my B value is just over 1. So it's not going up that rapidly. How long will it take for the investment to double? Well, so if it doubles, I'm going to have 10,000 equals 5,000 times 1.06 to the x. I could graph this on my calculator, put in 10,000, find where it intersects, or I can solve this algebraically. I'm going to divide by 5,000. Of course, it doubled, so I've got 2 on the other side. And my x is going to be equal to log base 1.06 of 2, which gives me, I wonder if this is, that's silly, I can't erase just part of it. So let's switch colors. That's going to give me about, so here we have to think about years. We're only getting money at the end of the year. So let's see what happens. Math alpha. Math. Log base 1.06 of 2. 11.8 years. So at the 11th year, I won't have hit my 10,000 yet. If we test this out and make that 511, we haven't hit 10,000 yet, so we have to go to 12 years. So 12 years to double. All right, so that's example 1.